So good afternoon, everyone, and welcome to this brand new lecture with a brand new topic.
Sir,
Yes, beta.
can you once explain the question paper? So we have doubt.
Uh, can you ask the doubt in the doubt class? I mean, let us start with the how many doubts you have. I don't have the question paper with me, so I don't know. I don't have the
Okay,
question paper with me. Which question you have doubt? Tell me.
5 to 10 doubts, 5 to 10 questions. Sir.
I don't have the question paper with me, beta.
Okay, next
Uh,
time.
mm,
So you can say in doubt session.
yes. So what we'll do is we'll have a doubt session, and I'll arrange a doubt session for you. Okay.
Okay, sir. Okay, sir.
Maybe during the weekdays we'll have a 1 or 2 hour doubt session. Okay, I'll arrange it, and then we can discuss all the doubts over there. Okay.
Okay, sir. Thank you, sir.
Okay. Let us continue with the class here in this session, and I will talk to the office people, and we'll discuss a doubt session. Okay.
Okay, sir.
Okay. Where I was. All. I mean, you want me to let us do this. I will discuss the doubt. Okay. Don't worry. Maybe tomorrow. I'll maybe tomorrow's class. I will not take the class. We'll take the doubts. Okay. Or you want to do it in today's class? What do you want me to
Yes,
take?
sir.
What, sir? You want me to take the doubts in today's class? Have you collected all your doubts?
No, sir. Next time.
So what you do is you collect all your doubts, send it to me via Telegram or your office, and then probably we'll take one of the classes at doubt classes and we'll discuss it. Okay.
Okay, sir.
Okay. Chalo. Then we start with this Newton laws of motion. That is the first topic we have, right? Anyone understands Newton's laws of motion? Yes or no? Now, as soon as we talk about Newton's law of motion, the first thing that we must encounter is something known as force. I hope everyone knows what is a force. Yes or no? What is a force? Force can be defined as a push or a pull. Have you heard this? Yes or no? Yes or no? Force can be defined as a push or pull. The better way of saying force or describing force is it is an interaction. It is an interaction between two bodies, at least two bodies. There must be at least two bodies, or a body and its surrounding, whatever is surrounding it. So whenever there are two bodies kept, or we have a body surrounded by other bodies, a body kept in a surrounding, bodies interact with each other. Well, what I mean by the term interaction is they influence each other. You understand the meaning of influence? They exert some effect on each other. That effect what that one body exerts on the other body, or the interaction between two bodies, is known as a force. Do we understand this? It's very simple. Now we have to understand force, so you can write it as point wise, or if you want to write it in terms of a paragraph wise, I will show you a paragraph that you can write and remember simple things about it. So the next thing that you must remember before writing that paragraph is what type of quantity is force. What type of quantity is force? Force is a vector quantity. Do we know this? The SI unit of force is Newton, and 1 Newton is 1 kg meter per second square. Everyone understands this? Yes or no? The dimensions of force, because it will be needed in the chapter on units and dimensions, and one question always comes from dimension. What is the dimension of force?
ml t to the power minus 2.
Well done. I always think that, and I always say that the NEET students are way more hardworking and better than the JEE guys, and you always prove me correct. So, if you want to write them in the form of a paragraph, you can write it in this way. I'll give you 1 minute to note it down. The only thing you have to understand is the important points. If you understand those important points, which I've written point wise, the paragraph is just a paragraph. The paragraph that I have shown is just how will I write it in the form of a paragraph, nothing else. I'll give you a minute. Once you're done, please raise your hands. Please let me know so that I can move forward. Remember, you must understand that we have gone ahead of the JEE people, right? Or yes or no? Do you understand this? The gap is widening. So it's good that we are going at a good speed and we are doing good. How was the paper, by the way? Paper was good or bad? This is good, this is bad.
Moderate.
What? Forward. I could not hear you. Just say, was it good or bad? Say na. I did not hear it. Arey, that was good or bad, or it was not good, not bad. Only three options.
Good, sir.
Good, sir. Okay. Still, you have doubts. We'll clear it. Don't worry. Okay. Have you noted this down? Have you noted it down, bacha?
No, sir.
Okay. I'll give you 2 minutes. Note it down. Once you are done, please let me know.
Completed, sir.
Okay. Everyone completed? Then we move ahead and we see what can be the effect of a force when applied on a body. So sometimes we may include it in the definition as what is included in the definition that you probably just have written. A force is a push or a pull which may either change the size or shape, change the speed, or change the direction of motion, or it can change both the speed and the direction of motion. So this is written now point wise. If you want, you can write it point wise. It may change only speed, it may change only direction, it may change both speed and direction. That means it may change velocity, it may change the size and the shape. The size and the shape of the body will come as last chapter in your 11th standard, so we are not going to take it right now. What are we going to take in the present discussion? We have been taking in the present discussion is 1, 2, and 3, changing only the direction, changing only the magnitude, or changing both. I hope you understand this. I'll give you 2 minutes to note this down. Fatafat, do it.
Completed, sir.
Everyone has done this?
Yes, sir.
Okay. Then we move ahead. Remember, this chapter is about remembering simple things. Though this chapter may look huge, but if you just remember these simple things that we are discussing, this chapter is relatively very simple. Okay. Now, when we talk about force, we talk about the various types of forces. Now, we'll just discuss them in very short. Now, this force can be classified in various ways. It can be classified in a number of ways. So whenever we talk about force and we talk about the classification of this force, fundamentally, if I talk about the nature of force, how this force comes into being, there are four types of forces, fundamental forces that we have found in nature. The first type of force that we found out was known as gravitational force or gravitational force. I hope everyone knows about this gravitation. Yes or no? The second type of force is known as electromagnetic. So basically it consists of both electrostatic force, force between two charges, or force between two magnets. The third type of force which will come in your 12th standard is known as strong nuclear force. And the fourth type of force that again will come in your next year will be weak nuclear force. In fact, in this year only, you will be covering gravitational force and some part of electromagnetic force. Electrostatic force and magnetic force, everything will be coming in the next year. Do we understand this? Okay. So these are the basic fundamental types of force. Now, what you must remember about this thing, the weakest of this force is gravitational force. So just remember this because this has come in your NEET exam many times. The weakest force is the gravitational force. Now you'll see, sir, how it can be weak because of this gravitation. Moon moves around the earth, earth moves around the sun, planets move around the sun, galaxies move around each other. But in fact, it is the weakest force in nature, is the gravitational force. And which is the strongest force in nature? Anyone? The strongest force in nature is the strong magnetic force, and this is the strongest force in nature. Though it only is effective over very short or small distances. But in those short or small distances, when we talk about distances inside the atom or distances inside the nucleus of a body of an atom, very short distance, this is the strongest force. But this is not effective if the distance becomes large. Over large distances, where the bodies are big, then your gravitational force, which is the weakest force, starts to look at the strongest force, but this is actually the weakest force. In fact, this electromagnetic force is stronger than the gravitational force. Do we understand this? But it is not as strong enough as the strong nuclear force. Now, one more thing that you must remember about gravitational force, it is always attractive in nature. You know this? It is always attractive in nature. Yes or no? But this electromagnetic force, it can be attractive. It can also be repulsive. Do we understand this? Yes or no? Can be attractive as well as repulsive. This force does not depend on medium surrounding it. So whether two bodies are kept in air or they are kept in vacuum or they are kept in hydrogen or oxygen or nitrogen or any other medium, gravitational force remains same, but this electromagnetic force depends on the medium. It does not depend on medium. It depends on the medium. So these are the small points that you must remember at this point. Remember these small points about these forces, we are good to go. You understand this? Yes or no? I'll give you 2 minutes to note this down. If you're noting it down, note down these points because they come as questions in your exam. I'll give you 2 minutes to note them down. Remember, we'll be discussing these forces in great detail in the chapter that is meant for do. There's a chapter known as gravitation. There's a chapter known as electrostatics, big chapter electrostatics. There's a chapter called magnetic field, big chapter on magnetic field. There's a chapter on nuclear force as well. When you come to that part, nuclear fission and nuclear fusion, then you will see nuclear force also. But right now, we just need to have a broad outlook of what they are. 2 minutes you have. Once you are done, please let me know, bacha.
Completed, sir.
All of you have noted this down? Okay. So we have seen the different types of forces that are found in nature. Okay. Now, in this particular chapter, and going ahead up till we come to a different point, your 12th standard, there are only two types of forces that we are going to be concerned with in this chapter, and work, power, energy, and all this chapter. We will be dealing with only two kinds of forces. What are the two kinds of forces that will come to us? It will be either gravitation force or electromagnetic force. Do we understand this? So these are the only two types of forces which we have to deal right now: gravitational force or electromagnetic force. If the force is not gravitational, then it has to be electromagnetic. Now there are many electromagnetic forces that we see in our day-to-day life. See, in our day-to-day life, we may not see strong nuclear force because it happens inside the nucleus, or when something happens to the nucleus. The weak nuclear force also we don't see in day-to-day life because it again happens inside the nucleus, and some decays happen, and that is why this weak nuclear force we came to know about. In normal day-to-day life, the forces that we see in every day-to-day life are either gravitational forces or electromagnetic force. And a gravitational force, because of gravitational force, I should not drop this pen. It damages it. Because of gravitational force, this pen falls down. Yes or no? We see it in day-to-day life. Because of this gravitational force, a moon moves around Earth. We see it in day-to-day life. But still, they are electromagnetic forces, which we don't know that they are electromagnetic in nature, but they are electromagnetic in nature. Example. This is, let us say, a table. Let me draw a table here. This is a table here. And you keep a block on the top of this table. Now, this block and this table also exert forces on each other. Apart from gravity, which is acting on this block and the table, gravity of Earth, there's also one force which happens between the two because they are in contact. That is known as the reaction force. And that reaction force, whenever you come across any force which is coming because of contact, 99% cases, it is a electromagnetic force. It comes because of electromagnetic interaction between the two bodies. This body M and this table, they are in contact, so their atoms and molecules are interacting with each other. Do we understand this? And they exert forces on each other. So all these forces which you see in day-to-day life are electromagnetic in nature. Do you know about friction? Friction comes because of contact. It is also because of electromagnetic. It's electromagnetic in nature. Tension in a string. You hold something by a string. Your string becomes tight. There is a force in the string. It is also an electromagnetic force. So whatever force we see in our day-to-day life are either gravitational force or they are what type of force? They are electromagnetic in nature. So in this class, we are going to deal with three types of electromagnetic forces. One is the reaction force, and one is the tension in the string. So these are the forces that we are going to deal in this chapter. Do we understand this? We'll come to these forces, but before going on to, okay, we can deal with these forces. So let us start dealing with forces, then we will study Newton's law. Newton's law everyone knows. So the first type of force that we are going to deal with is gravitational force in this chapter. So you can write gravitational force is the first type of force that we are going to deal in this chapter. Gravitational force. Now, when we talk about gravitational force in this particular chapter, we all know that gravitational force is the force of attraction between two bodies of mass m1 and m2 separated by a distance r. Yes or no? So if I have two bodies, let us say this is body m1 and let us say this is body m2, and they are separated by a distance of r. We have gravitational force between them. Yes or no? Can anyone tell me what is the gravitational force between them? Fg. F standing for force, G standing for gravitation. Newton's laws of gravitation. Anyone heard about them? Newton laws of gravitation. Yes or no? Either you have heard it or you have not heard it. It's as simple as that. No one heard it, it seems. Newton laws of gravitation goes like this. It is G m1 m2 by r square. M1 and m2 are the masses. G is a constant. Do you know the name of this constant? You know the name of this constant? I think we discussed it in the chapter on units and dimensions. No one remembers it? Universal gravitational constant. It is known as. We had also seen the units. We had also seen the dimensions. I'm not going to go into that. So this is the gravitational force between two bodies separated by a distance r. But in this particular chapter, we are not actually going to go into this formula. In this chapter, whenever we talk about gravitational force, we are going to talk about gravitational force of Earth. We will be talking about bodies that are on Earth, and we will be taking what is the gravitational force experienced by those bodies. So for example, you will have, as in the previous example, you will have somebody kept on a table or somebody kept on a ground, floor, surface, whatever, and the mass of that body would be given as m. So whenever, because this is a chapter known as Newton laws of motion or force, whenever you are going to get a body of mass m, the first thing that you are going to do is to draw the gravitational force onto it. And what is the gravitational force onto it? We will consider that whatever force Earth is exerting on this body is the only force of gravitation on that body, and that force will be always acting downwards, and that force will be equal to m into g, where m is the mass of the block and g is acceleration due to gravity. You know the value of acceleration due to gravity, yes or no? Do we know the value of acceleration due to gravity, yes or no? Yes or no? We're not sure about it? Yes, we know it. Okay, this mg is also sometimes known as the weight of the body, W. We know this, mg is known as the weight of the body. People may also call it gravitational weight. So the first force that we are going to draw on any body will be this mg. And what are the things that you must remember about this gravitational force? The value of this gravitational force that we will draw will be always equal to mg. And what would be the direction? Whenever we draw this gravitational force, what would be the direction? Remember, the direction of acceleration due to gravity is always taken as downwards. Do we remember this? Vertically downwards. Do we remember this? So similarly, the weight of this body mg would always be taken as downwards. So this is what we got to remember for this particular chapter. For this particular chapter, the only gravitational force acting on this body will be its weight. It will be always drawn downwards, and the value of that weight would be equal to mg. Do we understand this? I'll give you 2 minutes to draw this. If you want to write, please write. Don't forget it ever. Once you are done, please let me know, bacha. Simple things. And you will see how these simple things are going to help us coming forward. Going forward, not coming forward.
Completed, sir.
Everyone done this? Okay. First type of force that we are going to encounter is gravitational force. Now, sometimes we may encounter a block which would be placed like this. When I say like this, what do I mean? Let me draw it. Sometimes we may encounter, and that is the point where we might get confused. I hope you can see this. Sometimes there will be a surface like this at an angle theta, and then you will have this block of mass m kept on this. What will be the direction of gravitational force on this? Remember, do not draw it in any other direction. It is always downwards. Do we understand this? Do not draw it in any other direction. It's always downwards. So remember this. Anyways, the first force that we are going to see is gravitational force, and there will be only gravitational force due to Earth. The second type of forces that we are going to see are electromagnetic forces. They will be electromagnetic in nature. And in this, the first kind of force that we are going to see is known as reaction force. Is known as reaction force. Now, before going on to this reaction force, let us, since we have used this term reaction, let us go on to a law that instead of going into the first law and the second law, straight away move on to the third law. Newton's third law of motion. Anyone? Newton's third law of motion. Yes, anyone?
Every action have equal and opposite reaction.
Every action has
Equal and opposite reaction.
every action has equal and opposite reaction. So basically, it tells us if a body A is exerting force F on body B will also exert the same force but it will be same in magnitude but opposite in direction. We all know this, yes or no? If this is body A and this is body B, if body A hits body B has also hit body A, yes or no? You cannot touch anyone without getting yourself touched. There are different ways in which you can understand this. Action and reaction are equal and opposite, but they act on different bodies. Remember this, action and reaction are equal and opposite, and they act on different bodies. Everyone understand this, yes or no? Now, whenever you hear the term reaction, this is what comes to your mind, that we are somewhere talking about Newton's laws of motion. But when we talk about this reaction force, it has got nothing to do with, it's got obviously something to do with Newton's laws of motion, but this reaction and that reaction force are not same. When I talk about this reaction force, let me take it from here and let me put it here. And also let me take this thing from here. So let me cut this part from here and bring it here. So what I have done here, you can see, I've taken this everything off, and I have just put Newton's third law of motion on the upper side. Now let me talk about this electromagnetic forces. Now, when you talk about this electromagnetic forces, the first type of force that I'm going to deal with is reaction force. Now try to understand the difference between this one and the other one. Now, what is this reaction force? This is a surface. I hope you can see this. You have a surface and you have a body kept on this surface, body of mass m. Now, whenever two bodies are kept in contact with each other, no matter what their shape, no matter what their size, whenever two bodies are kept in contact with each other, they exert forces on each other. Whenever two bodies are kept in contact with each other, they exert forces on each other. That force that they exert on each other is known as the reaction force. Do you understand this? So that is what we will write. Do we understand this? Yes or no? Whenever two bodies are in contact with each other, they exert forces on each other. That force that they exert on each other is known as the reaction force. Do we understand this? Yes or no? Let us take the case of this body. This body, let us say, is moving with a velocity v. It is kept on a surface. It is in contact with the body. So both these bodies are exerting forces on each other. This block is exerting force on the ground. This ground is exerting force on the block. That force is known as the reaction force. Now, if I say that this R, the red R, is the reaction force exerted by ground on body A or body of mass m, then this body will also exert force on the ground, and that force will be exactly equal but opposite. Do you understand this? So this reaction force this reaction force is nothing but it is following Newton's third law. This R is the reaction force exerted by whom on whom? This is the force exerted by ground on body of mass M. This R is the force exerted by body M on ground. This R is known as the reaction force. This reaction force exerted by bodies on each other. This reaction force exerted by bodies on each other are going to be equal and opposite. Do we understand what I have written here, bacha? Yes or no? Everyone understands this? This reaction force which bodies exert on each other will be going to be equal and opposite. Yes or no? Shall we move ahead? Have you noted it down? You're clear with this reaction force? You're clear with action and reaction? Action and reaction are different. This is the force that they exert on each other is known as the reaction force. Sometimes we get confused. Now, as soon as we talk about this reaction force can be divided into two components. This reaction force can be divided into two components. The first component is perpendicular to the two bodies. The first component is perpendicular to the two bodies, and the second component is parallel to the two bodies. What do I mean by this? This is ground. A body of mass M is moving with a velocity v, let us say, on this ground. So this ground exerts a force R. This R is the reaction force. We understand this? This R is your reaction force. Now this R can be broken up into two components. One component is perpendicular to the two bodies, which is known as N. So this is your N. Oops. This is your N. And this is the component which is perpendicular to the two bodies. Then there is a component which is parallel to the two bodies. F. Do you know what is this F? Do you know what is this F? This is the component which is parallel to the two bodies. Do you know what is this F? Anyone knows?
Friction.
Yes. This parallel component is known as friction. Then what is this perpendicular component known as? See,
Normal reaction.
this is known as normal reaction force. How did you know the name of this one? Have you read it before?
Yes, sir.
Okay. Do you understand this? So, reaction force is the force between two bodies when they are in contact. It can be resolved into two, the parallel component and the perpendicular component. Parallel component is known as friction. Perpendicular component is known as normal reaction. Okay. Now, for the time being, we will just neglect this friction. Friction we will do once we are done with, and once we have moved ahead. Right now, we will not be concerned by friction. So the only force that we'll be concerned about right now would be your normal reaction. Do we understand this? Now, the name suggests that this is normal reaction, so it has to be always perpendicular. Do we understand this? So whenever we have to draw this normal reaction, let us say, for example, the body is kept here, mass M, it is kept in ground, so there will be a normal reaction coming from ground. Do we understand this? Apart from that, the gravitational force should also be drawn here, mg. We understand this? If the body is kept like this on this surface, how will you draw the weight and normal reaction? Can you draw it? The weight will be downwards. How will the normal reaction go? Upwards?
Perpendicular to the surface.
Yes, it has to be perpendicular to the surface. Let me take one more example. This would not be better, probably this one would be better. This is a block M1 and this is a block M2. What would be, if I ask you to draw the normal reactions, how will the normal reactions go on these two bodies? Okay, we'll come back to this question after a little while. So basically this normal reaction would be perpendicular to the two bodies. Do we understand this? Yes or no? Now, before going on to this diagram, let us do a small thing. Let us just understand a small term, and it will be easier for us to use that term, because if I've not told you a term and then I use it, that becomes a bit confusing. So before going on to that diagram of two masses, let us do a small term first. And the small term that we want to do first is known as free body diagram. In short, it is known as FBD. Do you know this term, free body diagrams? FBD, yes or no? What do you mean by a free body diagram? Now, since you know it, you can tell me what do you mean by a free body diagram? Just tell me. What do you know a free body diagram? So free body diagram basically means that is a diagram of a body isolated. Free means it is isolated from all the bodies drawn such that all forces acting on the body are shown so a free body diagram of a body is a diagram of the body which has been isolated. So you just isolate from the surrounding and then see what all forces are acting on the body and you draw those forces. Do we understand this? Now, having said that, and let me take you back to this picture, and I'll take a picture of this picture and I will post it here. Nothing I have done, I've just taken a picture of that picture and I have posted it here. So this was the diagram that we were talking about, right? Now, if I ask you, can you draw the free body diagram FBD of M1 and M2? The question is very simple. Draw FBD of M1 and M2. Can you draw it? You will have 2 minutes to do it. You know a free body diagram? Yes or no? You have heard about it? Yes or no, bacha? Yes or no? You have not heard it? Have you heard it? Yes or no? Yes. Even if you did not heard it before, now you have heard it. Now, can you draw the free body diagram of this? It's very simple. You have to do what is written. Have you written the definition of free body diagram? You just have to do that. Can you do it? Say, for example, if I just give you an example of a free body diagram, what you see here in this red thing, this is the free body diagram of this block M. What you see in this red is the free body diagram of this block. That is what you need to do with M1 and M2. Can you do it? I'll give you 2 minutes. Can I do it then? If you're not doing it, shall I do it? Shall I do it? Okay, then no one is saying anything. That means I'll have to do it. So what do? I isolate the two bodies. This is body 1. I'll keep it here. This is body 2. I'll keep it here. This is block M1. And this is block M2. Has anyone drawn the free body diagram? No one has drawn? Okay. Then I'll draw the forces acting on M1. Can you tell me what are the forces acting on M1? Do it fast. We have 2 minutes left.
mg downwards.
Not mg, it is m1g. Mass is m1. Okay, m1g downwards. What else?
Normal reaction perpendicular.
Right. So there will be a normal reaction. From where this normal reaction is coming? That blue one? It is coming from the ground. Do we understand this? This normal reaction is coming from the ground. Do we understand this? Let me call this as N1. Is it all, or there is something else that we need to draw? Now see, these two blocks are also in contact with each other. Yes or no? You can see these two blocks are also in contact with each other. Yes or no? Yes or no?
Yes, sir.
That means they will also exert forces on each other. The lower block will push the upper block, and the upper block will push the lower block. Yes or no?
Yes, sir.
These will be equal and opposite. Yes or no? Let me call this force as R. So this force also becomes R. So I need to also draw these R forces which is coming because of contact. The upper block will push it downwards. So I will have to also draw. I will also need to draw this downward force. Oops. Yes or no? So I will have to draw this R force. So this force will be going perpendicular like this R. Do we understand this? This force is this force. Do we understand this? Exerted by M2 on M1. Now if I draw the free body diagram of M2, what happens? M2G is downwards. Then this ground is giving it normal reaction. Let me call this as N2. Why am I using different numbers? Because they are different bodies. This block is again pushing the block M1 is pushing the block M2 upwards. So I also need to draw that. That will be this R. Do we understand this? This R is the reaction here. This R. Do we understand this? So this becomes the free body diagram of body 1, and this becomes the free body diagram of body 2. I have isolated the two bodies and drawn all the forces. Do we understand this, everyone?
Yes, sir.
We will move ahead with the same discussion in the next class. We will discuss more on free body diagrams and draw more free body diagrams. Okay, so we'll do that in the next class. Take care and have a nice day. If you have any doubt, beta, please come to me. Bye-bye.